balancing can be done in two ways. First is called as active balancing. One is called as active balancing and one is called as passive balancing. In active balancing, we are adding the mass or we are subtracting the mass. So we'll add it or we'll subtract it, but extra quantity from a given system to achieve the balancing is called as active balancing. In case of passive balancing, without addition or removal of mass from a system, if balancing is achieved by manipulating the inherent parameters of the system is called as passive balancing. You can change the condition of the wheel. So that is called as passive balancing. But which one is more popular? Active balancing is more popular. Types of balancing in two parts. One is revolving mass and one is rotating mass. Revolving mass, as you have seen, the single mass, or we can have multiple mass. And multiple mass, we can have a same transverse plane or we can have different transverse plane. Like this one, this is a situation of a single mass. And is this single mass here? Is it a single mass case? Now this one is a single mass, but is it the same transverse plane? Is the transverse plane is same? And this one is a multiple mass, and is it a multiple transverse plane? One mass is here, one mass is here, one mass is here. They have different transverse plane. So multiple mass we'll discuss in two stages. One in single plane and one in multiple transverse. These are called as transverse plane. This perpendicular to axis is called as transverse plane. Similar to this, receding masses will be also classified into single mass and multiple mass. So rotating system will be something like this. We have a piston, we have a cylinder, we have a crank and connecting rod. So is this piston will reciprocate? This piston will reciprocate. So if it will reciprocate, and since it is rotating with a uniform angular speed, so because of this one, will it have a acceleration along this one? So because of inertia, it will produce the balancing problem. And because of this one, all reciprocating engine cannot be operated at high speed because balancing is a major issue. But I cannot open it right now. We have to see the derivation for this one, and then we come to have certain practical difficulty there. Okay. So and then we'll go for this one, whether the balancing of rotating mass is 100% possible or is not possible. So that is different issue. In multiple mass system, we have a same transverse plane but different axial plane. And second case is that different transverse plane but same axial plane. We can demonstrate two cases. One is this is a V engine. So this one is what? Same transverse plane. And this one is your car engine. So if the car engine has a different transverse plane. One is V engine and this one has the same transverse plane. V engine is normally used in racing cars or is very popular for helicopters because it is very compact. This one is very popular for the automobile, that is car engines or buses and what it may be. And because of this one, it will produce a centrifugal force. So centrifugal force will show this way, that is Fc. So this centrifugal force is m into omega square multiplied by r. Simple way to balance this is to have a single mass mb. So what is mb? Is balance mass. Available for this one, we'll attach this at radius equals to rb. So rb is the corresponding radius. Now since we are one plane only, there is no question of couple produce. So only condition is to be met is sigma fy must equal to 0 or summation of all forces must equal to 0, that in general. So we have this force is, and this force will go exactly opposite of this one. So we have m into omega square multiplied by r equals to mb multiplied by omega square multiplied by r. So only necessary condition is that we should have the product of m bar multiplied by mb multiplied by rb. So actually we have two variables. One is mb and one is rb. Either you should know the radius, then we can find out mass, and if you have a mass, then we can find out radius. So this equation has the problem. It can only produce one controlling equation. So one thing you have to adjust. Sigma f has only produced one equation, but we have two unknown. So either RB should be known, then we can calculate MB, or if MB is known, then we can calculate RB. Vice versa. Let's consider here a one shaft, and we have three planes. That these planes are transverse plane, and let's assume that they are supported at this end and at this end. Let we have a three different masses of different magnitude at different radius. So let's say this is at this position. Let's call this one is M1 to R1. Let we have different mass here equals to M2 at a radius equals to R2. And let we have one more mass somewhere at this point equals to M3 at radius equals to R3. And this shaft is rotating. If the shaft will rotate, will it produce a centrifugal force in this direction? So this will produce centrifugal force in this direction. This will produce the centrifugal force in this direction. The centrifugal force is this direction. Now this process we can represent on the bottom figure. And we want to find out that how many masses are required to balance it. Let's say we have one force here. And let's say we have 1 point equals to A and 1 point equals to what? B. So let's say this force is F1. And from here to here, we have a distance equals to A. And from here to here, distance equals to B. And the total distance equals to what? L. Considered. As far as this figure is considered, for this figure is sigma Fy is minus of F1. Sigma Fy, I will say just F. It is simply minus F. At the same time, is the moment of this force about point A is equals to clockwise. Is it F multiplied by A? And is the moment of this force about point B minus of F into B. Okay. Now what I will do is that instead of writing this force in one part, I will write this force as this one. Okay. So I am purposefully doing this. And I will write this condition equals to what? F1, and this equals to what? F2. So for this equation also, is F1 minus F2 if same as previous value of minus F, then are these two systems are same system. Or we can put up the condition like this, that F is always equals to what? F1 plus F2. Second thing is that if I take this point equals to A and this point equals to B, and if I take the moment about point A, what is the moment of force about point A? So moment of force about point A equals to F multiplied by A from the previous case. If the same moment will also generate this system, then is both systems are equivalent systems. So if I want to produce the moment of F1 about A, 0. What is the moment of F2 about A? Is F2 multiplied by what? L. So can we calculate F2? Is F what? F multiplied by A divided by L. And if I use the second condition, I can directly calculate the value of F1. Or otherwise you can put this value back here, and are we able to calculate value of F1? So idea is that can we divide one force into two forces? This system is same as this system. Original system has been converted into two unbalanced forces, that is R1 and R2. To balance R1, we attach M1 at a certain radius equals to what? R1. Let's call this one is MB1, RB1, and to balance R2 exactly in opposite position, I will place MB2 at radius equals to what? RB2. So any number of masses we have in a transverse plane can effectively balance by only two masses at two different planes. That planes are called as reference plane. This one is reference plane and this one is reference plane. Now it is your job where you want to place the reference plane. So depending upon the space, they can be adjusted.